Alright, so here we have Slim Jim, who is also an astronaut, and his spaceship is at rest when he shoots his space cannon. So we know that before we have 0, since the object's at rest, and then he shoots a cannon. So afterwards we have the momentum of the spaceship, so m1 v1 afterwards, plus the momentum of the cannonball, so m2 v2 afterwards. Okay, so what is the mass of the ship? The mass of the ship is in kilograms. It's 2,500 kilograms. Alright, what is the weight of the ship? Well, in space, the force of weight is mass times gravity. In space, you don't have gravity. Gravity is 0, so it's actually 0 newtons. Force of weight, so it's going to be in newtons. Alright, calculate the final velocity of the ship. So we're going to take our conservation of momentum equation. 0 equals, the mass of the ship is 2,500. Velocity is what we're trying to figure out, plus mass of the cannonball was 1.5 kilograms, and its velocity was 800 meters per second. Alright, so we end up with 0 equals 2,500 v plus, and then we have to multiply 1.5 and 800. So 1.5 times 800. And it's going to remain positive because it's moving to the right. Okay, and we get 1,200. So 1,200. Alright, so to solve for v, our first step would to be the 2,500 is stuck to the velocity. So we can subtract 1,200 and end up with negative 1,200 on the left side times 2,500 times the velocity. Now to solve for the velocity, we could just divide both sides by 2,500. So we end up with 1,200 divided by 2,500. That equals our velocity, which is equal to negative 1,200 divided by 2,500, and we get negative 0.5. So it's going negative 0.5 meters per second. Okay, and it's going to make sense that it's moving backwards since the cannon's moving forwards. If we have a momentum of 0, a net momentum of 0 before, we're going to have a net momentum of 0 afterwards. So if the momentum of the cannonball is 1,200 kilogram meters per second, the momentum of the spaceship has to be negative 1,200 kilogram meters per second. The reason that the velocity is so much less is because the mass is so much more. So which has more momentum afterwards, the ship or the projectile? Where they're the same. They're equal and opposite.